Alright, I'm gonna go ahead and work out number 9 right here. So I'm gonna put it down here. Go ahead and see what it says. An individual named Claudius is located at the point 0, so right here in the accompanying diagram. Using an appropriate randomization device, such as a tetrahedral die, one having a 4-side, Claudius first moved to one of the 4 locations, which would be B1, B2, B3, B4. Once at one of these locations, another randomization device is used to decide whether Claudius returns to 0 or next visits one of the other 2 adjacent points. This process then continues. After each move, another move to one of the new adjacent points is determined by tossing an appropriate die or coin. A. Let X be the number of moves that Claudius makes before first returning to 0. What are the possible values of X? Well, alright, so this section is on discrete random variables, and so a random variable, which is here going to be X, is going to be defined as it's going to take, assign numbers to elements of the sample space. So I guess first we need to determine what on earth our sample space is. So, let's see here. Well, that's the number of moves that Claudius makes before returning to 0. The sample space must consist of maybe all possible combinations of moves. That might be right. Let's take a look at that. Alright, so we always start at 0. So we know this will always start at 0, and we'll go ahead and write this as a tuple. And so the rules are that we first must move to B1, B2, B3, B4. So the only options here is going to be 0, B1, 0, B2, 0, B3, 0, B4. And so 0, B1, and then we get some other options after this. You know what? This might actually work really well with a tree diagram. Let's do a tree diagram, because that will make visualization easier. I don't like tree diagrams that much, but we'll just have to do it here. 2, 3, 4. B1, B2, B3, B4. Okay. Start at 0, we go to any one of those. Once at one of these locations, another randomization device is used to decide whether they return back to 0 or visits one of the other 2 adjacent points. Okay, so I guess on this, if we're at B1, the options are to go back to 0, right? To go to A1 or A2. Okay. Then at B2, the options are, again, to go back to 0, and then to go to A2, A3. Okay. B3, the options are to go back to 0, but instead we go A3, A4, and then B4 will be back to 0, or A1, A4. Okay. Cool. Alright, so now that we have this, let's see what happens after that. When this process then continues. After each move, another move to one of the new adjacent points is determined by tossing an appropriate die or coin. Okay, so this continues to infinity, I guess, and beyond. So, but all we're concerned about is whether or not, what do you call it? When we get to 0, right? That we go 0, 0. So if we go to 0 to B1 to A1, oh, that's a key word, one of the new adjacent points. But that doesn't make sense, because if we go from 0 to B1, and then the A1, and then the B4, and then we either go to 0 or A4, but if we do end up at A4, B3, and then we go all the way back around, but when do we go all the way back around to B1, but B1 is a point we've already been at. So if we are at A2, that means you're stuck. You can't go either way. What a mess. Okay. Well, I guess what we'll do here, then, let's just continue to map him out. We'll stop here, because this is one way. We'll just map him out and just see until we get stuck, I guess. So, yeah, I guess I keep it moving. So A1 is saying that we can't go, we need to move to the new adjacent point. Okay, yeah, let's just assume they mean new, like we've never been there before. So we can't go back to B1. Okay, so let's go, we can either go, or we're forced to go to B4 in that case. And then from B4, we could potentially go to 0, and then, or we could go to A4, and from A4 we have to go to B3, and then from B3 we could potentially go to 0, or we could continue on to A3. Whew. Okay, then from A3 we can go to, we have to go to B2, and then it becomes 0, A2, oh no. Okay, we're gonna have to get another sheet of paper here. Just kind of put it under it. So that will continue using it. And we'll mark where the paper is going to start. Okay. So you know where to put this paper on top. Okay. Where were we? A2? Okay. So we're B2, A2, and so from A2 we have to go to B1, but we can't go to B1, right? Because B1, we've already been there. It's not new. So this would be, we'd basically be stuck. We would have to, we can go to A2, but there's no new point we can go to. Okay, so let's go ahead and just kind of leave this be, and let's do another one. Let's do the A2 here, and we'll see if there's a pattern. But we can tell you right now that based on this, we know that if X is the number of moves, if X is our number of moves that Claudius makes before first returning to 0, and we want to know basically the possible values of X, what that could be, that I guess you'd say the range. Well, we already know that it's going to be, what is it, the number of moves before, so he makes 1, 2 moves, okay, 1, 2, 3, 4, okay. 1, 2, 3, 4, 5, 6, okay. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's an interesting pattern. Okay. And then it cuts out right there. Okay, interesting. Ah, let's do A2. Let's see what we got. Okay, so we go from 0 to B1 to A2. And from A2, we're forced to go to what, B2? And from B2, we can go to 0 or A3. And then from A3, we have to go to B3. Okay. And then from B3, we can go to 0 or A4. Okay. And from A4, we have to go to B4. And then from B4, we can go to 0 or A1. And then we're going to have to write these papers again. Should have matches. There we go. Okay, so from A1, where were we? Right here, we have to go to B1. But we can't go to B1 because we already went up here. Okay. So now we got that. Let's see. Since this is a, what do you call it, the range for X, we don't have to include, if 2 happens again, we don't have to add it back to that set. So let's just see what happens. So we have 1, hold on, 1, yeah, 1, 2, 3, 4. Okay, 4 is already in there. 1, 2, 3, 4, 5, 6. Oh boy, okay, 1, 2, 3, 4, 5, 6, 7, 8, and then it can't go beyond 8. I wonder if this is going to repeat for everyone. Well, I guess let's find out. See if we can see what the pattern is. So first of all, 1, 2. So we're going to go to A2 now. And A2 is our corner. And therefore, we're going to be forced to go to B1. Oh, yeah, I'm seeing the pattern here. Then we go to B1 or A1. And from A1 we have to go to B4. And from B4 we can do 0 to E4. And then from A4 we have to go to B3. 0, A3. Alright, then from A3 we have to go to from A3, sorry, 0, then B3, A3. What was I? We have to go to B2, but B2. So, very similar deal. So we go 1, 2, 3, 4. That's already in there. 1, 2, 3, 4, 5, 6. That's in there already. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 2, 4, 6, 8. It appeared to be the range. Okay. And then with A3. Okay. Pattern. B1 to A2. A2 to B2, B2 to A3, A3 to B3, B3 to A4. B3. It's reversion. Wait. I don't know. Okay. We'll just keep looking it up. Okay. So B3, and then from B3 we have a 0 and A4, and from A4, sorry, A4 we have B4, and from B4 we have 0, A1, okay, you see this is interesting, so we're going the other direction, but it doesn't matter. Okay. B1, and then B1 is 0, A2. And from A2, we have to go B2, but we can't do that. So, try to look that up. B2, but we can't do that because we started up there. So, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So 2, 4, 6, 8. So I'm getting pretty convinced here that it might be 2, 4, 6, 8. Because no matter where we start, no, the light went out. Some truth. The light comes out. Go turn it back on. Sorry for the delay. Yeah, anyway, where were we? B3. So, B3 to A3. Then from A3, we have nowhere to go but B2. From B2, we have 0, A2. And from A2, we have to go to B1. B1 is 0, A1. And then from A1, we have to go to B4. And B4 is 0, A4. And then from A4, we have to go to B3, but we can't go to B3 because B3 is up here. Okay, so, yeah, it's the same thing. 1, 2, and then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so I'm pretty convinced that we have the answer here, that the range at the sample space, which is all of these combinations or the tuple or whatever you want to call it, it's going to be assigned a number 2, 4, 6, 8, and that would be the random variable and how that works. So x is it discrete or continuous? Just make sure this is the word possible values either constitute a finite set. Yeah, so it's the possible values are 2, 4, 6, 8. This is a finite set. So this is definitely discrete. Alright, so that was 9, and unfortunately this was just A. So we need to see what B is going to access for. So let's see here, get some more paper. Alright, 9B. Okay, if moves are allowed also along the diagonal path connecting 0 to A1, what diagonal paths? So I guess they're saying we create diagonal paths. Yeah, I guess that's what it's saying, is that we literally, have a diagonal path here and go 0, A3 there. So I'm gonna guess a similar pattern is going to occur here. So again, it wants us to determine the range of our random variable, and the range is going to be some set of numbers. So I think we're going to have to do a tree again, unfortunately. So again, I don't like trees, but there's no way we're going to do the problem with that. So let's go ahead and start at 0. There we go again. Okay, so now we have a lot of choices now, right? Because we can actually, instead of it 1, 2, 3, 4, we have 1, 2, 3, 4, 5, 6, 7, 8. Great. Alright, we're gonna have to stress it out. 1, 2, 3, 4, 5, 6, 7, 8. Good enough. Okay. So we'll just start with this. We'll say 0 to A1. We can go 0 to B1. We can go 0 to A2. We can go 0 to B2. We can go 0 to A3, 0 to B3, 0 to A4, and then 0 to B4. These are all the possible moves that we can make here. So, if we go from 0 to B1, then the options are going to be the same as before, right? As if we have 0 to B1, and then we have all this, so it's going to repeat. So B1 is going to repeat, B2 is going to repeat, B3, and B4 is going to repeat. And that means we already know the range to have at least the number 2, 4, 6, and 8. question is, what new numbers are this going to bring in? So we're going to just do it. So starting with A1, assuming we have diagonals of A1, we can return to 0 or go to a new adjacent point. So we're at A1, we can return to 0. We can go to B1 or we can go to B4. So let's assume the universe that where we actually want to B1. If I want to B1, I can either go to 0 or I can go to A2. So let's presume we somehow went to A2. From A2, we have a diagonal, right? So A2 can go to 0 or B2. And B2 can go to 0 or A3. And A3 can go to 0 or B3. B3 can go to 0 or A4. And A4 can go to 0 or B4. And B4 can go to 0 or A1, but A1 would not be a legal move because we have A1 up here. So let's see what number we come up with now. So we got 1, 2, then we have 1, 2, 3. That's a new number. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And then finally 1, 2, 3, 4, 5, 6, 7, 8. So basically the range is gonna be 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to have the presumption that A2 is going to follow this pattern, but we better make sure. So let's double check. Looking at A2. A2 we have 0. Wait a second. Oh no. I only want B1. I didn't go to B4, did I? Okay. Let's go from A1 to, I guess, B4. Let's just see what happens. We can't go backwards, so we can only go 0, A4. We went to A4, we can go 0, B3. And then from B3, we can go to 0, A3. A3 we have 0, B2. B2 we have 0, A2. And then from A2, we have 0, B1. Did we already go past B1? No, A1. Okay. In B1 we have 0, A1. Can't go to A1. Okay. I think it's the same situation, but let's double check here. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the same situation. And then let's just get a feel for A2, because A1, well, technically, if we notice these squares repeat and the options and the number of moves are the same no matter which corner we start at. What I mean is, we start at A1, we have to go 1, 2, 3, and then each move, it's symmetric, meaning if we start over here, we can flip this over, and it won't matter that whether we started over here or over here, because it's symmetric. So the movements we make are going to be the same. So I'm going to say we don't have to check the others by symmetry. The other path will be the same. Alright, so the answer to number 9 is this right. So we're gonna double check out the answer in the back of the book. So this is number 9 of chapter 3.1. Okay. So 2, 4, 6, 8. That is 2, 1, 2, 2, 2, 3. Well, it looks like we got it right, but it's saying that this is an infinite sequence, but the question said you had to go to a new adjacent path. You can keep going round and round, but yeah. So it is, even though it's an infinite sequence, discrete because it's countably infinite. So we can say this is discrete, but yeah, I don't know, I might disagree with that. Let's go back to the original wording. Process then continues after each move, another move to one of the new adjacent points. If they didn't have new or just one of the adjacent points, I mean, that answer is agreeable, but I don't know. Well, we got the question right in essence, and so that's pretty much what matters in the end. Let's see. Yeah, I think that's good for today. Anyway, thank you for watching. Make sure to like and subscribe so I know what content to keep making. Have a good evening. See you guys soon.